Okay. So I've been posting the links in the chat. So if you have just joined us, maybe you can actually take note of the slides, and that's where this link is, will bring you to the slides. Okay, there's our slide -30 July 2020. And then in the slides, you'll be able to see all these links as well. All right. So some house rules before we begin. Basically, I think most of us already have renamed ourselves with our personal name. That will help us to get to know you better, especially when you bring up a question, we could address you. I think that's more polite as well. So by default, all of us are muted except for the presenters. And if you have any burning questions, you could also unmute yourself or maybe bring the questions to the end of the session. We will try to have that at the end of the Q&A, especially if we have ample time. We highly encourage you to switch on your videos. At least I'm not, looking at the small little black boxes. I do get to see some expression and some body language or cues from you. So we encourage you to switch on your videos. And also please go ahead and put in your questions or anything that you have in mind in the chat. We hope that this is going to be an interactive session, since we only have about, how many of us? About close to 50 participants so far. It's a cozy session for all of us. And yes, this session will be recorded. It's a very popular question. It will be recorded and uploaded as well. And at the end of the session, we have a short survey for you to fill up. Okay. So this session will be recorded and be used for NUS libraries, communications and promotional purposes. So if we take pictures, just say cheese, okay? All right. So before we begin, I would like to know a little bit about where are you from and which department. Maybe you could use your mobile phone to put in a response, okay, in this link here, polliv.com/mag. Okay, let me put that up as well. Okay. Or maybe, let me try out. Yes, I'm seeing responses coming in. Okay, so if you could go to polliv.com/mag, we'd like to know where you're from, which department. Okay, from the previous sessions, we see people from medicine, science. Okay, we do have SOM as well today. Do NUS econs. Okay, today we are not seeing our folks from engineering yet. Okay, yeah, so this link is where you can actually put in your responses, polliv.com/mag. Okay, yep, thank you for your responses. We have from FASS as well, business, computing, right? So like I always encourage, in the previous sessions, we have people who are out there who are really advanced in R. If you see any questions on the chat and you would like to respond to it, please feel free to help out with the question as well. It's really about learning together. So we would like to foster that learning environment within this Zoom session as well, okay? Nice, okay, so we'd like to know what is your role in the department? Are you an undergraduate student, graduate student, researcher, and etc.? Okay, so we are seeing quite an even spread of graduate student and researcher, faculty member, okay, undergrad students. So welcome in. Thank you for giving us this information. It'd be good for us to know. Okay, and it helps Dr. Tan when he actually try to pitch his information, he will know how to gear it accordingly. Okay, so we have actually about 30% of you are from a researcher background. Okay. Good. And also, I mean, we have been running this series. I think this is like the last session, and we have 5 sessions in all. All right. So I would like to know whether have you actually attended the sessions that we have ran previously. Okay. I think about 60% of you actually attended 4 sessions. Okay. Half, at least 2. Okay. So I'm seeing that, you have some background, I suppose. Okay. And if you don't have any background in R, you could actually type it into the chat so that we know the percentage as well. Okay. So nevertheless, I will not just skip this introduction, since most of you have actually have seen Dr. Tan before, but he's no stranger to us. He's a research fellow at ALSET, the Institute of Applied Learning Sciences and Educational Technology. And I think he pretty much uses R every day at his work. Okay, I'm not sure about, over the weekends, but at work, I'm sure, it's a day in, day out kind of a software that he goes to. So we really appreciate, okay, on behalf of NUS Libraries, thank you so much, Dr. Tan, for giving us your time to share your knowledge and also to share with the NUS community on how to use R. Okay, and if you have any questions, and we have been receiving questions on our software, our codes, they actually approach Dr. Tan. And if you have any research project that you actually want to explore further, you can actually approach Dr. Tan, and let's look at what are the options out there for even research grants and all that. Okay. So this brings us to the last session of this series, what we titled it, Elegant Data Visualization using our ggplot2 and part 3. So in part 1, part 2, we have covered pretty much the ggplot2 graphics, okay, how we modify these graphical displays like your title, labels, color, and font size, and that's in part 1. So, and in part 2, Dr. Tan actually explained further going into the theme systems. And this is really about the add-on packages using the theme systems that he talked about. And he even introduced what was really new to me about the GUI theme. So, and I'm excited to hear from him this in part 3. And I think this session is really catered for color of graphs. And we are going to see a suite of colors in the slides. And Dr. Tan, over to you.
All right, thanks, Meg.
Okay, I'm going to stop share. Yeah.
Hi, good morning, everyone. Thanks for coming back for this third session. Yeah, today is mainly on colors. So you can see a lot of colors in all the slides. So if you are fond in colors, to use it in your graph. So this probably is an appropriate session. But the color packages is quite a lot. So we just cover a few of them. So that you can search specific colors that you like to go on to the add-on packages that you want to use it, right? So basically today we're going to cover the color scheme that used in the R package. First, we introduce what is called color names. So you can use a name to specify a color names to use in the graphics output. Then we'll introduce something called the red, green, and blue models, and how we're going to use the hexadecimal codes under this red, green, and blue models. And we'll introduce the ggplot that is there's available, the color palettes that is available in ggplot2. Then the next session, we introduce what are the add-on packages that we can use on top of what is provided by the ggplot2, like the RColorBrewe and the Wes Anderson. And basically, we use we illustrate using these two packages for a few examples. And then we introduce some other add-on packages that is available. And we end up with the last session using annotation, which is available in the ggplot2, and an add-on package called ggrepel, which makes the text arrangement in the ggplot output more flexibly. Yeah, this is what is discussed in the last session. So probably it's just to introduce that to make the concept more clearer, to say that after you installed the add-on packages, one way is you can put all the packages in front and run all at one time before we go on to the other the R code syntax. Another way is when we want to use ggplot2, then we load it, then we write the codes here. Then if we decide to run the color space, another add-on, then we load the library, then we go on. So both way will do, you see. Yeah, so it depends on which way actually that facilitate you better. And another one that we discussed in the last session is when you load in the library ggplot2, some of the syntax appear here is the following object is masked from as a package stat, which is this function is called Louis. When we see this package, that means that the there's this particular function called Louis is used in this add-on package called ggplot2, as well as stat. Stat is the base package. Once we load in the R, it will be there, you see. Yeah, so this means that after we load in the library ggplot2, the Louis function that is used in ggplot override the stat package. So this Louis is available in stat, available in ggplot. The syntax actually is similar for this example, but some of the syntax could be totally different. Yeah, so what it means is that when you load in a library of ggplot, you override the first one that's just loaded. Yeah, so this is what is the ggplot, the Louis function produce. It just put a smooth line over a scatter plot for this example. So we go on to today a workshop theme is color scheme that used in ggplot2. So there are 657 color names that's available to use in R. So we just simply type in colors, then we'll get the list of the colors that in the console. And these are the syntax to print. I'll just briefly go through the syntax, then we'll go on to R to see how actually generated. We are not going to explain in details for this R syntax. It just briefly tell you that what is the things that is available in R. Yeah. So what this syntax generate is to create a data frame that store X and Y of 34 rows and 19 columns. So altogether, there would be 665 cells generated by this X and Y, or rather their X and Y exit position. Yeah, so the rest of the syntax is the geometry rectangular will print a white patch because what is syntax generate is this color. So these are all the color names that is available in R base. So the first line print the bar of the colors. The second line give the names of the bar that is above it. So the white patch is referring to is this because there are 657 available color names. So 665 cells would exit the 657, so it leaves the black patch with its 8 cells. So the second geo rec is to print the color bar, and the geo track is to print the color names. So the bar is the color of the bar, then the next line is the name of the colors. Let's go to R and see how. So presumably that this installation has been there, right? So we just close it. So first we generate all these libraries, highlighted and put Control R. So to let it loads all the libraries here. Yeah, so simply Control R and print and it will print on the console this 657 colors names. So there's the names of the color that you can use to generate a plot by specified specific colors. For example, blue. Blue one, different degree of blue. Let's say a gold color, and so on and so forth. And a list of gray colors that range from gray 0 to gray 99. Yeah, so there's different colors of gray. Because let's say some researchers like to publish in the publication, some journals, articles, which still do not allow for coloring, then probably the gray will play a part on this. Yeah, so these are all the 657 colors, right? Yeah, so if we go on to generate this and press Ctrl Enter, then we'll get the one that is appear on the slides. You can just drag it over. So a gray 51, gray 52 will be that colors. Gray 0 will be totally close to dark colors, and so on and so forth, right? So let's say a yellow green will be this color, a yellow will be this color, a yellow 4 will be that color, and so on and so forth. So this is the one that is generated by this set of syntax. Yeah, now we introduce what is called blue. This is more like the concept behind. Then we go on to generate the graph later on to see how we can use this color to specify into a color that we would like to output graph. And we introduce here is a red, green, and blue models. Short form is R. The symbols is RG. Stand for red, green, and blue. And the red, green, and blue is, you can see the red, green, and blue here. So the red, green, and blue is saying that we actually human can visualize these three colors. And if there's a mixture of these three colors, then the color will change accordingly. Yeah? Let's say the gray and the green, if we specify these two, will turn to yellow. Then the colors here is by combination of green and blue. Then if there is red, green, and blue is all specified, then it become white. If none of these are specified, it become a black color. Yeah, so this is how it combines these three colors. These three colors, the specification of these three colors is by specifying a number. If everything is in red, then it's 255. Then none is specified for green and blue, it becomes 0. So another way of specification is instead of ranging from 0 to 255, it becomes 0 and 1. That's another way of specifying. And another way of specifying is to put it in hexadecimal specifications. That is to say, followed by the hex size, the first two characters is red color, followed by the next two is green, and the last two is red. It's blue, I'm sorry. Yeah, so that is a hexadecimal. Hexadecimal is different from a decimal. A decimal is running from 0 to 9, then going to 10 to 11, and so on to 255 is what we are familiar with. And those is computer science, they probably is very familiar with this hexadecimal in computer. That's the hexadecimal is 0 to 9 will be the same, but 10, because it's a 16-digit style of system, 10 will become A, 11 will become B, until 16 will become F. So the system of numbering is actually ranging from 0 until F. So if we go on to 16 of a decimal, it becomes 10 in the hexadecimal. Then it becomes 11, 12, 13, and 14 until 255 is represented by FF. So this way, representation of hexadecimal is rather convenient for sums. To say that it's actually just required 6 digits here, instead of having a specification of 0 to 255. So that is how the hexadecimal come into play. So we can use either RGB specification of this that range from 0 to 255 or 0 to 1 or specify a hexadecimal type of system to generate a color. So this is some of the examples of generating colors using specified, let's say the color names we just now, we say we specify colors and then bracket, then we generate all the color names for 657 colors. But sometimes it's quite difficult to remember all these names, except those that we are familiar with, pink, blue, orange. But beside that, it's hard to remember something like spring green, or this color as well. Yeah, so one way is to specify the colors we want, is saying that how we're going to mix these three colors called red, green, blue, and green. Yeah. So from the one extreme is saying that we have the blue, then the specification is everything is in blue. Nothing is specified for the intensity in red and green. So everything in blue. Then the specification in blue in RGB is 00255. So it's 00255. Then green is become 0255, 0. So everything is in green. Let's say it's in red, then everything is in red, 25500. So if we didn't specify anything, is 0. We specify everything is, all the three colors is in high density, then is become all with the value is 255. Yeah. So the hexadecimal is, this is 0, so it's 00. Green is 0, is 00. The value of 255 is actually FF. So you can see that is 255 is actually FF. So it's FE is 254 and so on. Yeah. So if there's only specified two colors, green and blue, without the red, so it can is 0, FF, FF, right? So this is the colors. So the color star here is saying that if there's a mix of blue and green without the red, it becomes this color. So the same thing, yellow is specified with red and green. Without the blue, it becomes yellow. So yellow is with these two colors, red and green, without the blue, then the hexadecimal is this, become FF, FF0. So it's FF0. Yeah, then if we vary the red and blue, vary the degree of become red and blue, here is orange. Orange is somewhere here. So there are more red color component, but there's less green, but without the blue. So without the blue, 255 is for the red, and the green is only 165 somewhere in between. Then we generate the orange color. So it's so on and so forth. Let's say a violet. Violet is somewhere a high density in red and blue, but less in green. Then we generate violet. Yeah. So the table summaries here is then that these three colors absorb these three colors, but reflect the other two, and the RGB specification is that. So we can also specify this 0255255 with this specification, right? With the hexadecimal here. Yeah. So that's the basic concept of a red, green, and blue models. That's to say, we can choose the combination of these three colors to generate all the colors that we want, instead of relying on color names. Yeah. So there are functions to generate this, to convert colors into, to convert the names into hexadecimal. That is the function is called color to hex. A usual specification in the naming of functions, the 2 is always represent TO in R. They like to use the 2 to have a short to represent TO. Yeah, the same thing, color to RGB is it turns the color names into RGB specification. Then RGB to hexadecimal is RGB, that's from the base. So we need to load that's why we need to load the gplot in order to get this function. So we will load this, call in this gplot by giving the name of 20 color names here, from blue, green, red, all the way to navy, and we store it into a vector called color1. Then we use this function called from color to hexadecimal, read in the vectors from here, then the hex1 will store the hexadecimal code. If we put in color to RGB, then we turn this hexadecimal to RGB. Then we just transpose it. Then we put them all together and store it into a data frame called this. Then we print the output here. So the color is blue, which is the hexadecimal code is this, and while the RGB specification is 00255. And so on and so forth. And to navy is 000080 with 000080 is 128 for RGB specification. Yeah. So how to turn this RGB that range from 0 to 255 instead that is range between 0 and 1 is to put in max is equal to 255, this argument. That is to say RGB 001 will have this output. This output actually is blue color. And if we put in the argument, is 00255, then maximum is 255. We also generate the same code of blue. So either specification will do. Yeah, so the same thing go for the green color, the same thing go for the red color. And let's say we generate something that is 1620240 with a high density in the blue, then followed by the red, but less in the green, then it will generate the hexadecimal code here. I think I'll skip this. I just generated this. Yeah. So this is I think this is another way of you could refer to this slide as well. Instead of having the name, the color names specified below the codes, these are the hexadecimal code that is print below the color bar. That is the 657 color codes. So we can use the color names. We also can use the hexadecimal code here. So, and another way is we are not going to explain in details for the syntax from now on. Yeah. So yeah. So another way is this is actually copied from on the website and then just modified. So another way is we can print this. I thought this is a good output. So the green, the blue, and the red is here, so that we the red ranging from 0 to 1 according to the RGB specification, and also the green that is ranging from 0 to 1 as well here. And then we'll see that when the green is approximately 1, so it's everything that is in greens, and then there's 0 for red. Yeah. So you print it as green. So you can refer to this color map here or color space here to pick the RGB specification from this particular color space. Yeah. Now we are saying that after we know that what is color, we can use color names, we can use hexadecimal, we can use RGB specification. How we're going to generate the graph that using this tree specification. So we refer back to a very common data frame that we use. Yeah, so probably you'll be quite familiar with this data frame. Yeah, so it's an empty car data frame that record the 32 mobiles of car models that from 1973 to 74, and we pick. This is the names. These are the the variable that is available in this data frame for the 32 cars and the 11th variable. We choose two of them. One is called MPG, one is called the WT. MPG is the miles per gallon for that specific car, and then the WT is the weight of the car. For instance, Mazda RX-4 is with MPG 221 miles per gallon, and the weight is 2.62. Then first, we want to generate the plot. So the S, we store in the object SO by plotting using this data frame, empty cars. And we specify the x-axis is MPG, the y-axis is WP. We say we want to generate a scatter plot. Then we give a title, it's got default colors, because we didn't specify any colors we want to use for this plot. So what they chosen is black colors. So we're saying that x-axis is mile per gallon, so it appears mile per gallon here. Y is car weight. So you can see that the higher the car weight, the lower the miles per gallon. So that is a scatter plot that is used here. So if we want to specify, we're using hexadecimal, then we put in, instead of just 0 point that generate a scatter plot, within it, we say color is equal to this hexadecimal. Then you generate this color, a bit like gold color here. Yeah, so we put a title, say use hexadecimal, field is equal to this, then you appear here, right? So if we use the color name is red, then what we have to do is just color is equal to red, right? Then we have a red scatter plots appear in this scatter plot diagram. We also can specify color is equal to RGB 0.1, 0.8, 0.5. So green is higher in content, right? So the red and the blue is lower. So we generate something that is closer to green color. So this is how we specify, using a color. Default, using hexadecimal, using the color names, and using RGB. 3 ways of specifying to change a scatter plot to another colors. We'll go through this, then we go back to the R to generate this. So the previous slide is saying that we changed we specify only one color. So we can input either the Excel color names or RGB into the 0 point. Yeah? So if we want to change the colors according to another variable, which is the cylinder. The cylinder of the car is either 4, 6, or 8. So we want to do that, then we put in the aesthetic to say colors is equal to factor CYL. The reason I put in a factor here is because cylinder is stored as numeric 4. So if we want to generate the colors, we turn them into factors in order to generate the colors that is differentiated by CYL. Yeah, I'll just put in T minimal, we covered in the last session. That means quite minimal things that is being specified for the team. Yeah, so the title, the XY is all specified here. So if we want to specify more than one colors, we have to use the scale color menu in order to input, to turn into that colors. So we specify the color name red, blue, and green. So there's red, blue, and green here. So you turn into red, blue, and green here. We can see that those with a smaller cylinder 4 is around here. Those with a high cylinder is here with higher weight is for the car, right? Yeah. So let's say we want to change it into another color. So it is black, pink, and salmon. Then it becomes black, pink, and salmon. So if we decide to use RGB, then we can specify the RGB values here. Then we have RGB color specified by the values here. Yeah. So we have to follow the same syntax. using scale color menu, values is equal to that. Right? So that's the syntax. Let's go back to generate this. So this is the one that generates the output, that produce this. I added on that if it's 00255 can be 001. This is just added yesterday. Yeah. So it's just to add in another line of syntax. Then you can produce both the range 0 to 255 or 0 to 1 by taking the original value divide by 255. It's as simply as that. And this is the one that generate the color space of this, right? So you can see it from here. Then we generate the car, empty cars examples. So generate from SO until that. So that will produce the specification using the default color, the hexadecimal, the color names, and the RGB specification. Right? Then we go on to the next one that generates multi-colors using the scale color menu. Then that so we stay here, we generate output, then we go back to explain. So we don't need to yeah. So this is using another examples from the base. It's called the iris flower. So we generate this, we highlight this, then we generate the plots. So we generate a violin plot with a different colors. The default using the hexadecimal, using color blue, the color name, and specifically on RGB. Right? Then this is only generate one colors, so we can also use another function, right? Another function, which is called the scale fill menu. Right? The generate, there's a default colors. This is specifying using color names. This is also another using another color name. So let's go back to the slide. Yeah. So we're saying that we, because we're generating a violin plot. A violin plot, as its name indicates, it looks like a violin sometimes, not all the times. So it looks like a violin, it looks like a violin shape. That's why it's called a violin plot. So we want to generate a violin plot is we read in this. Oh, I think I forget to introduce the data set. Sorry about that. So we get the data from iris. Iris consists of 150 observations that record the sepal length, sepal width, petal length, petal width of a flower, of the iris flower. Yeah, so this is the petal and that is the sepal. So they measure the length and the width. And then they record three species of these three types of flowers. So each have 50 observations. Then it record all these three types of flowers. So it consists of 150 observations for 150 flowers. And with these three species, Sentosa, Vesicular, and Virginica, right? Yeah. So this is what is this data set about? So here we are saying that we get from this iris data set, we want to specify the species on the X, so that's the 3 species. And the sepal length, we want to know how the sepal length look like, the distribution of the length. So you can see Sentosa, the sepal length is much lower than the one in this species. So this species has a wider sepal length. Then vesicular is somewhere in between. Right? So most of them of the Sentosa is about length of 5. So here somewhere in the middle will be 6. And this one is probably around 6 point something here. But there's a quite a bit here also that range from 7 to 8. This is how we look at variant plot. So a variant plot will become more common compared to a box plot, which is only indicate the 25, medium, and 75. So variant plot actually is a better plot than a box plot that traditional use in when the computer is not available. Yeah. So in order to generate the variant plot, we put GeoViolin. Okay? Then we said the title is default, so we print a default here. Yeah. So that is the base that generate this. Store an object called VO. So we get back the GO without specifying all this. Then we add on that the field is equal to this with a hexadecimal code. Then you produce this color. Then we will go on to say blue. Then we produce the blue. Then we specify the RGB will produce another color. Yeah. So the difference between using about this is just to change the GeoViolin into GeoPoint. You change it to the plots that we intend to produce. Yeah. So that is the next one. Taking from the same data sets, then we're saying that we want to put the species on the x-axis and the sepal length on the y-axis. And we're saying that the field is equal to species. So to fill the colors from the species with a different colors. So once we specified that, then that is the default color chosen by ggplot2. Yeah. So if you want to change, we have to introduce a skew fill menu that specify it to be the red, blue, and green. Then we'll generate a plot, a variant plot that is colored by red, blue, and green here. Then if we will say sky blue, pink, and salmon, then it's sky blue, pink, and salmon. The basic difference between a variant plot that is using the field here and the scatter plot is using the color here, because the field is a variant plot of this field with color. You just probably can just view it this way. So the field has to be used. But the scatter plot is just a plot. It's just a dot. So you have to use the color. So instead of color, skew color menu is for scatter plot. Skew fill menu is for variant plot. Let's say we do a box plot that has to be filled with color, then we have to use the fill instead of the color. So there's a difference between the fill and the color in ggplot. So there are built-in color palettes as well. This is a 5 color palettes that we can use. So that we do not need to. We do not need to. I can't be a teacher. So.
Do you happen to have a cup of water?
Yeah, I do, but yeah.
Okay.
Yes, but it's cold already, so I did not drink it. Thanks. Yeah. The previous examples, we have to specify the colors we want to use. Let's say color names is red, blue, green, pink, and so on and so forth. So there's a default colors that is already in R when you load. One of them is called the rainbow. So we need to specify how many rainbows colors we want to use it. Then in this instance, because we're generating a barcode with 8 bars, so if we say rainbow is 8, then we produce 8 colors. That's rainbow colors. Yeah. So geocore is to generate the bar. So if we say heat color, that is the heat colors. And we said terrain's color, this is terrain color. So it's more green and brownish style. There's quite a terrain terrain style colors that we want to have it to generate it. So topo colors is this, and then CM color. So this is the default colors color palette that is available now without specifying any hexadecimal or color names or RGB. So to summarize it is that there are 657 color names you can use. We can also specify a hexadecimal code. We can also use RGB, right? So when when we want to use more than one colors, we use the scale menu function. Fill is for we illustrated with violin. So bar plot, box plot, all this is under fill. So there's some spaces that you have to fill in colors with this fill. Let's say if it's a line plot where we don't need to fill in a line, but a line, then we use the scale color menu to do that. Or even the line together with the point together in one plot. Then we use the scale color menu function. Yeah, having said that, we're not going to illustrate an example. It's just to say that beside the scale fill and scale color that is available for doing these sort of plots. Yeah, there's a gray color scale that's also available in ggplot2. It's called scale fill, not menu. Menu means we have to fit the color to the function. It's called gray. And also scale gray color. Then we'll produce something like the box plot here, which is gray in color. And also a scatter plot that use the color gray to generate the scatter plot. So beside the menu fitting in a gray color specification that use these two functions, there's another called the gradients color. The gradients colors, there are 3 of them, is sequential, divergent, and gradients between n colors. We have 2 examples here. This is a histogram. So those that is lower in observation is in blue colors. So when I go up, the counts about 20 it turns into red colors. So this is called a gradient colors. It specified 2 ends of different colors, and then in between the colors changes, right? So to show that high in red, blue in low observations. You can see from here, high here, low at the 2 extreme. Right? So it'll be useful. Let's say you do a color scatter plot using the gradients function. In this instance, we use color because this is fill, so fill is still red. So we can see that sample width here, sample length here, those sample length have a high in observations will printed in this color and low printed in blue as well. So that is useful when we want to specify a range of colors with a different frequency or weights or count that to differentiate by colors according to the weights and the counts. Or some other weighting mechanism behind. Yeah. So far we have we'll talk about the colors that is used using color names, using hexadecimal, using RGB, but is using ggplot2, right? So, but we can still use more colors that is built by some other author that built on the add-on packages. We introduce color, one of add-on packages that is consists of the color palette is RColorBrewe. This package divide the colors into three classes. One is called the sequential palette. You can see that we illustrate with blue for this package, that if those that is the blue colors actually from very faded type of color from close to white colors, they're all the way up to very dark blue. So that's why it's called sequential. And let's say we get another example is green, also from very white, then very thin type of green, then to dark green. And sequential palette also can change according to color to say very yellow, light yellow, and then all the way changes and then to very dark colors. So a divergent plateau will illustrate with spectral. Spectral divergence means in the middle there's a white patch here, or even very light yellow, but two extreme with two types of different colors. So let's say for this one is very brownish, then to turn to very light, and then all the way to green color. So those as low values will be somewhere in between. Let's say something that is negative, probably in brown in color, something positive in green color. So you can always play with this divergence, either using sequential or using divergent plateau that's under this package called RColorBrewe. And qualitative palettes is something that is what to distinguish between, let's say, category. So we have 3 categories probably, or 5 categories, or 10 categories. Probably we can choose any of these so that the color is quite distinct. So it's meant for qualitative type of variable under this package. This is I do not know this person until I know about this package. Wes Anderson is an American film director that very good in using colors to generate the films under his direction. Yeah. So these are 1, 2, 3, 4 films they've produced. Yeah. So that use a very different color settings. You can see that his color palette is very colorful, and he seems to quite like a bit about pink. You can see a lot of pink colors here, and very contrast coloring. So you can see his film is actually quite related to the color palette that is specified here. So there are 20 colors that is available in this package, and that is the syntax to generate the name of the colors palette. You can see that you're going to use draw year 1 and draw 2. You can see the firms is related to this is the raw year tenable. So just cut and paste. As you can see, the pink color here, the red color here, the red color here, the pink color here is all related to this particular movie. So probably people like this movie of Dog Size. So this one is find here. Yeah. So this color, this films, you can find some of the one of the color plateaus that is quite related to this one, right? And then pink colors, another films that is of these colors, very related to these colors, the background of that, the dressing, and so on and so forth. So that's why this package is named as package Wenderson after the name of the director, film director. Yeah. So we will we'll explain this. Then go back to our program to run it. We generate back. We use back the same data frame. It is iris, is the flower. So we specify the species on the species on the x-axis and the petal length on the y-axis to generate the box plot using the color palettes that's in these 2 packages, and as well as using the hexadecimal and the skew field gray. Yeah. So in order to use the color RColorBrewe package, we have to use another skill field that is brewer, that is to get the color palette from this package. So first you have to load this package, then we use this particular skill to get in the color palettes. So dark 2, spectrums, and blue is this. Blue, dark 2, and spectrum. So using the colors here. And Wes Anderson use back the skill field menu because that package we have to specify the brewer in order to get drop, but the package when there's use back the ggplot2, so we can still use back the skill field menu. So it depends how the package is being built by the user. So for Wes Anderson, we can use back the ggplot function, while for our color brewer we have to add in the brewer. So Royal 1 and Royal 2, which is these two colors that we're using. So the hexadecimal, we just specified 3 of them here. And then the gray one, we just specified the skill field gray here. Then we put all this 8 box plot using the grid arrange to put them into one output. So that's the default we do. We prefer this color, I think it's fine. So we use a dark 2, that is what is produced. Dark 2, right? Dark 1, I think. Dark 2. Oh, this is a qualitative patchy for dark 2. There's another dark 2. That's the blue. And this is Royal from Wes Anderson. Royal 2 from Wes Anderson. Specified using hexadecimal and specified using the grayscale. Yeah, let's go to R to generate this. So we just scroll down. So this is a color built in. We just generate this. So you get just now that one using the default colors palettes. There is like rainbow and CM colors. Then if we use the RColorBrewe and Wes Anderson, first we load the package. This will put it in. Then we generate the 8 box plot. So that produced the 8 block plots with different colors. Then back to the slide. Yeah, so you can see that there's a lot of options to generate colors. So it depends on your color preference, depends on whether you use an add-on package like RColorBrewe or Wes Anderson. If you're satisfied with that, then it's okay. But there are much more packages available now. See, that is the good things about R. You can choose whatever you want. But there's the bad things about R. So if you're not satisfied, then you have to go on searching for the colors that you want. Otherwise, you have to specify the colors you want, right? Yeah. So that's to introduce the color package color space. That is another package that they differentiate between the qualitative, sequential, with single and multiple. That is and also divergence. Yeah, so you can this is just to list the color palettes. So if you think that that's the color palettes that you think you prefer, then you load this package and then use it and then specify the color palette, the color palette that you want. Right? So this is show more of the for this color space that's using HCl palettes, but it's different from the red RGB specification. Right? So I'll leave you to find out what is HCB. The references at the back you can, if you're really interested in the colors, you can read more on this about this another color specification. You can see there's a lot to choose from here. And there are some interesting add-on packages as well. So that's why there's one session for this color, because there's so much things that is available now. There's one package called Visualize. It's based on the theme of fish color, I suppose, that to produce it. And there's another package called ggSCI, which some of the color palette is related to the journal's article requirement of the colors. So this is two of them. American Association for the Advance of Science, they require this style coloring, and that is the New England Journal of Medicine. So you can choose from this package if you are interested. If you intend to publish a color output to send to the journals. I suppose that the user take care of all this. That create this package called GGS. Another package called OCHRE, which is based on Australia Arts, Landscape and Wildlife, that to produce the colors. Then yet people that is have colorblind, then there are packages that that produce colors. Let's say this is default colors. Then this package called colorblind, just using commands, they'll turn into colors that's suitable for the colorblind to visualize it. So they have difficulty in this, but they don't have difficulties in this. But that depends on what type of colorblindness that the person is suffered from. Yeah, so there's a normal vision. Oh, I'm sorry, I forget to put on the laser. Yeah, so it depends on, there's a normal vision. That is different type of colors blindness that the person suffered from. I say this is purple in color, but people that is a tritanopia, they are seeing this color. That at the very extreme, if people suffer from color blindness, they can see only black and white. So, yeah, so this package colorblind raw, then is for color blindness. There are other two packages, ggteam2 and Pictromet, which a color can, which a person that can only see two colors instead of the trees. Then you can use this package as well. Right. So this is one there are add-on packages that allow us to generate different other type of colors besides the colors that we just mentioned. Yeah. So, and there are colors that is based on Disney theme. There are colors that is based on the landscape, based on glass, and then this color that is called our zone, that is based on fish colors, based on some like grasshopper, based on flower, based on kingfisher bird. Yeah, so this is available in this package, right? Yeah, so there are plenty colors add-on colors package that you can refer to. Yeah. Here list 19 add-on packages you can refer to. Some of them is really listed there. This is, I think, this is based on some Japanese cartoon or something. If I'm not wrong. Yeah. So there's another package is Game for Thrones. I will produce these colors and the American map. So 19 listed here, but there are much more. I just listed 19 here. So if you're really interested in colors, you can just Google it, and then you get all these colors add-on packages. Yeah. So we talk about colors. now we switch on to another topic called how we're going to add text into graph. We'll just show a few examples, and then we'll show our output without explaining the syntax. And the syntax is available in Alpha. So you can just generate and modify it from the syntax that's given in the Alpha, right? Yeah. To add text, one way to add text into a graph is to use a function called annotate. So this is like we say that we store a text here called package ggplot function annotate theme b black and white. So a black shares n means go to the next line. So there's a blanks here before the package ggplot is printed. Then another, go to the next line, print function annotate, then go to the next line, and then theme by. Huh? So to add the text, we just simply say generate ggplot, annotate is text starting at the position of 4 and y is equal to 25. The size of the text is 8, and the label of the text is taken from text. Text, it is this one, text. Huh? Then we add in the title, subtitle, caption, X and Y, title, subtitle, caption, X and Y. Then you produce this block. So if we want to repeat the text, we can say that annotate is text that is starting from X is equal to 2 to 5, so it's 2, 3, 4, 5. Y is at the same, Y exit is at 25 here. Then the size of the text is 8. Then get the label of the text with this text. And then you put text. Yeah. Then followed by the theme and the specification of the title and subtitle, caption, X and Y exit. Yeah. But the thing of using annotate in ggplot2 is sometimes text can overlap. And if you put in a lot of text using a specific variable that attached to the position of the text that you want to print it, can become very clumsy. The text is not very well separated. Huh? So add-on text called ggrepel is just doing wonderful. I just have to read in this text, they'll arrange automatically for you. Let's say for instance, we want to put the text here, we specify the position. Then another text here, specify another position. That is very troublesome, right? Yeah, so what we'll do is we go on to use back the same data frame called empty cars. The empty cars have, I think, 32, right? 32 observation. But we are not going to use the 32 for illustration. Just select 10 cars out of the 32. So the way to do it is first we use the data management package called dplyr. That we can use a function that is called sample n 10 to select 10 observation from the empty cars. And then the select function will say we only want these 3 variables. So this sample n select is a function after we load this add-on package. Then we can use this to do a selection of variable and selection of observations. Yeah. So we're not going to cover in detail here because it is under more on data management. Yeah. In order to select the same 10 observation, the set seed specify any number here will generate the same set. If we do not use a set seed, every time, let's say without this statement, every time we go through this, we'll select a different 10 observation. So that is the set seed command here, because I think we mentioned this before. So probably just illustrate those that have not attended the previous session to say that what is this set seed command is about. That is set a starting point that you select randomly, you produce the same output. Yeah. So all these will be stored, this 10 observation will be stored in a new data frame called mtcar10. So the mtcar10, read from mtcar, select 10 observation, only include these 3 variables, and then we store it into a new data frame called mtcar10. And this name is not a variable in the mtcar. It is the row name of mtcars. Row names mean it is not part of the variable, but is a name for each of the rows. So we just take the row names and then store into mtcar names, then you will appear as this. So in order to generate non-overlapping type of text, we have to read in the library, is it ggRepel. Then we generate the ggplot here, saying that we read from the car, so it only consists of 10 cars. WT is on x-axis, MPG is on the y-axis, the label is equal to name. So dual point that printed with colors, red, so you can see the color, red colors dot here. And dual point is to generate a scatter plot. Then with the specification of title X and Y will store into TO. Then if we use the geotext, it will produce the text here. And then you can see that the text here is overlapping. If we use the geotext, which is available in package ggplot2. So if we want to have the text that is separated here, it won't overlap. Then when we use the ggRepel, then instead of using using the geotext here, we use geotext repel, which is a function available in ggplot. Then you automatically generate the old non-overlapping text. So to summarize, if you're using ggplot geotext, probably is not preferred if there's a lot of text that we want to plot without overlapping. Use the ggRepel, then the geotext repel will take care of the overlapping. Yeah. So the rest of the slide, we are not going to explain the syntax. We are saying that if you're using ggRepel, in fact, let's say if you draw something that is there are some points that is very different from the rest of the points, which we're saying that are probably the outliers, very different. Then you give a name to it. Then we can use the ggRepel labels. Then if we have to draw something that is which is less than 3, which is less than 4, with the appropriate text being printed, then with a line that is drawn to the plot, that is also can be done in ggRepel. And if we want to have a vertical text, horizontal text, and then with a line pointed to the plots, the scatter dots, then that also can be done in using ggRepel. And with using the direct label package with a function called jodl, we can even differentiate the points with a variable that differentiate them. In this instance, we are plotting the engine displacement in little and the highway miles per gallon. We can see there's an inverse relationship with that. But if you want to differentiate between what types of vehicles, let's say a two-seater, so-seater is probably around here, sub-impact probably is around here, and then the mid-size is probably around here, right? So the compact is probably those are printed in brown color is around here, and use this particular package. Then another package is the ggforce. The function is geomark ellipse. Then you also, those points that is very closely related, they were enclosed with ellipses. Some ellipse is small, some ellipse is bigger. And then you point out that the ellipses is belong to which type of car models. So that is another package that is available for text. Yeah. So I think we're not going back to the R codes to generate. It can just generate itself, right? Yeah. Probably just to give some of the references that you can refer to in the webs. So I'll probably won't go through the slide, but we point directly to the website. Right? I'll stop this, and then we go to the website. So this is the ggplot, is a cookbook for R. Cookbook for R is a book written. Then this website will have a section on color. So you can see that these are the color output here. So you can refer to this website, and then the syntax is all there. The next website is the ggplot itself. I'm going to create our own discrete scale. That is, they'll give example here, right? And another website maintained by this Michael To. So there are some examples here. They have tutorials here, and then there are examples here as well, right? And another one is quite a number of chapters on that, and one of the chapters are on colors. And then you can see that you can even have a density plot here, a field with colors, and so on and so forth. That produce quite colorful graphical outputs. And then this is I'll back to this in the slides, but there's a web page under Journal of Statistical Software that is touch on colors as well, right? And then that's when we talk about one specific package that provide color palettes for the scientific journals. You can refer to this web page. Yeah, so to show you examples of the journals that you want to submit to, with the color specification is already set in this add-on package. So that is another website. Is our graph gallery. So they produce some syntax together with the output. You can see that they actually draw outer with different colors from the field. Yeah. So they make use of the color, then also the field, both features. And that is another PDF file that is talking about HCl based color palettes. And then there's a reference for gggrepel that gives you the examples how to insert text. And then the last one is another website that gives you the text insertion for the graphical output. So back to the slides. So these are the web page that referring to. So for this, if you're really interested in the color, then you probably can refer to this particular article that they recommend that if you are into studying the gene, there are 24 pairs, so you must use 24 color and all that. And talk about different, we talk about red, green, and blue. There are some other type of color spaces that is discussed here, so you want to refer to it. And then we'll cover all this. And that is another HCl based color that is using the package colorspace. It's different from a red, green, blue specification. They talk about huge, trauma, and luminate, which is of the colors. You can see that this is a output from using some classification technique called support vector machine that differentiate the two classes. But that is something that is white in color to differentiate using the brightness of the colors. You can see that the brightness, change in the brightness of the colors using this particular package called colorspace. So, and last, not least, but then Magdalene and the two supporter always there for that. You wouldn't be so smooth without them, right? Yeah. They're the one that behind all the scenes for this particular job.
No worries, Dr. Tan. Thank you so much. Yeah, for sharing with us. Really, this session is an eye opener for me, as I can see that how I can change the colors into the graph that I want, and even using all the add-on color palette packages. Yeah, thank you so much for sharing with us. So I think that marks really the end of this session. And if there are any burning questions, maybe you could unmute yourself, maybe because we have a small group with us, and then you can unmute yourself and maybe give us your question. Dr. Tan will try to answer that as well. So if not, you can actually put it into the chat if there's a need for us to address it. Else, I think we have a feedback form for you to put up. Maybe I could share the screen again. Okay. So let me share my screen. All right. That's the one. Okay. So if you could, maybe you can give us your feedback and spend a minute with us for any improvement or anything that you have in mind, a question. Yeah, please feel free to put in your feedback here. You can actually scan the QR code as well. Okay, else, let me pop over to the chat and see whether are there any burning questions. Okay, no, I think we are good, I guess. Okay, so thank you so much for everyone for your time, for spending with us. Thank you.
Okay, thanks. Bye-bye.
Bye.
Hey, thanks, Dr. Tan.
Thank you.